Geometry students, we are going to get started on the second part of 5.1, angle bisectors of triangles. And you're going to be able to identify and use angle bisectors in triangles. In the first part, we were talking about perpendicular bisectors. So now we're going to talk about angle bisectors. Okay, so you might want to write this vocabulary down. And when three or more lines intersect at a common point, they're called concurrent lines. So it has to be three or more lines. The point where concurrent lines intersect, that is called the point of currency. And the point of concurrency of perpendicular bisectors is called the circumcenter. So this has to do with perpendicular bisectors. Okay, so if you notice, point P right here is the point of currency for lines A, B, and C. Pause the video, make sure you have this vocabulary written down in your notes. Okay, I asked you a couple days ago to make sure you had all the theorems written down in your packets. So make sure you have this theorem written down in your packets, the circumcenter theorem. Another theorem, or two other theorems that you need to have written down, the angle bisector theorem and the converse of the angle bisector theorem. Pause the video if it's not written down. Make sure you understand it. If you do not understand it, rewatch it, reread, okay? Because we're going to be using these for the problems that we're going to do here in a few seconds. Okay, so we need to find xy, and we are actually going to use the angle bisector theorem. So we know this is an angle bisector theorem because these two angles are the same. So this xz is an angle bisector. And we know that these are equidistant from each other because they form perpendicular lines. So xy then is going to be 7. And that's because of the angle bisector theorem. All right. Let's try a couple more. So in this one, we're going to find the measure of JKL. And this is the converse of the angle bisector theorem, because as we can see here, the line segments are equidistant from this point. Therefore, we know that KL is an angle bisector. So this is also going to be 37 degrees. So the measure of angle JKL is 37 degrees. Okay, now I want you to pause the video and find SP. I want you to do this next problem. Okay, so you could have seen in your packet that you're using the angle bisector theorem. And because of the angle bisector theorem, you can set 3x plus 5 equal to 6x minus 7 in solving for x. And when you do so, you're going to get 3x equals 12, x equals 4, but we have to find SP right here. So when we plug that back in, that 4 back in, SP is going to equal 17. Alrighty. Again, rewatch this video if you need to. If you need to rewind, please do so if you do not understand how I got that. Okay, our next portion of this section, angle bisectors of a triangle are concurrent at their point of currency, and their point of currency is called the incenter of a triangle. So here's the incenter theorem. Make sure you write this down in your packet and read it and understand it. So using the in-center theorem, we are going to find JF and the measure of JAC. Let's focus on JF first. JF is right here. Okay. So we know that JF is part of this right triangle here. Okay, we know it's part of this right triangle here. And based on our theorems, we know that this, since EA is 12, we know that FA is 12 as well. Well, we can use the Pythagorean theorem to find the missing side of a right triangle because we know this is a right triangle. So we can call JFA for now for the sake of using the Pythagorean theorem. So we have A squared plus, we'll say this is, well, here I'll write out the Pythagorean theorem so we all remember it and have it written down in our notes. So A squared plus 12 squared equals 15 squared, where 15 is our hypotenuse. It's opposite the right angle. So A squared plus 144 equals 15 squared is 225. Then we have A squared equals 81 because I subtracted 144 from each side. To get A by itself, I'm going to take the square root of both sides. A equals plus or minus 9. And we can have negative distance, so we know A equals 9. Therefore, JF equals 9. So that's how you find the missing side. Now what about JAC? Now JAC is this portion right here. How am I going to find that angle? Well, let's go ahead and look at the big triangle. All these three angles. Okay. So I know that this is 34 here. Since it's an angle bisector, I know this is going to be 34. Oh, there is an announcement. So here we know that this angle is going to be 68. And we know this angle is going to be 64. And we don't know what angle A is going to be, so we can take 180 minus 68 minus 64 to find it. And when we do so, we're going to get 48. Okay? And since JA is an angle bisector, 48 can be divided by 2 and we can get 24. So that's how I did that. I took 68 and 64 because I can add these two together because of this angle bisector. And I can take 180 minus 68 minus 64. Get 48 divided by 2 and I get 24. So the measure of angle JAC is going to be 24. Now keep in mind, there is given information for this problem that I did not tell you because I didn't assume anything. The given information was J is the in-center of this triangle. So that's why I could do all that stuff, is because this was given to me and I did not write that out. I apologize, but J is the in-center of triangle ABC. So make sure you add that to your notes. Okay, and that's why we can get all that information because of this given information. I would like you to continue with the homework, page 329, 1 through 30 all. You should be able to do all of it now that you have had this video. Come with questions. I will be checking your notes, so make sure you have your notes with you in class. And I look forward to seeing you tomorrow. Everyone have a great evening. Bye-bye.